All right, guys, let's go ahead and prepare for our exam. We're going to do the first one. Change 16 over 25 into a decimal form. I know every fraction is really a division problem. So this is nothing but 16 divided by 25. I know I can go ahead and put my decimal here and annex a 0. Now 25 goes into 160 how many times? Well, I know that if I multiply it to 6, I'll get 150. And that leaves me 10. I can annex one more 0, and 25 goes into 100 4 times. So that gives me 0.64. All right, now it says change this decimal into a fraction. I know I can change any decimal into a fraction by, or excuse me, any decimal that doesn't have a line over it into a fraction by putting a line under it in place of its decimal, and then putting a 0 under every number that's there, and then put a 1 in front of those zeros. Now I have to reduce. I know both of these can be reduced by, let's see, I think that 2 goes into both of these for sure. I also think 4 goes into both of these, so I'm going to go by 4 first. And that's going to give me, well, 32 divided by 4 is 8. And I know that 100 divided by 4 is 25. I think that's the best we're going to be able to do because no number goes into 8 and 25. Let's change 0.28 repeating, 28 repeating into a fraction. Well, the rule is if a line is over all my numbers, instead of zeros underneath it, I can put a 9 underneath it. So I would simply put 28 over 99. And I'm done. I don't think there's a number that goes into 28 and 99 to reduce it, so I'm pretty sure that's it. Now I have adding two fractions. I remember I have to have the denominator the same. In order to do that, I can multiply any number to 1 in itself. So I'm going to go ahead and multiply 2 over 6 by 2 over 2, because 2 over 2 is a fraction. Every fraction is a division problem. This division problem is 2 divided by 2, and that equals 1. So I'm allowed to go ahead and multiply this to 2 over 2. Well, 2 times 2 is 4, and 6 times 2 is 12. So now I've created a new fraction that is equivalent to 2 over 6, and that fraction is 4 over 12. Now I can add the two numerators together and keep the denominator. 12 stays the same, and 4 plus 5 is 9. I have to remember to reduce. Both of these can be divided by 3. And that's going to give me 3 over 4. All right, let's move on. Here I see that I have 2 and 2/7, and I don't have to minus 5 over 7. Well, at least my denominator is the same, but I can't take 5 from 2. So I'm going to have to go around the world to create an improper fraction. 7 times 2 is 14, and 14 times, or plus 2 is 16. So this is really 16 over 7 minus 5 over 7. And suddenly this doesn't seem so hard. Remember, when I'm adding and subtracting, as long as my denominator is the same, I don't have to mess with it at all. 6 minus 5 is 11. And I know every improper fraction, well, I can turn it to a division problem. 11 divided by 7. 7 goes into 11 one time. That gives me 4 left over. So my answer has to be 1 and 4 over 7. All right, next I've got 2 mixed numbers to put together. So let's go ahead and start. I'm going to go around the world again, and this is going to give me 4 times 9. That's 36, and 36 plus 4 makes 40. So this is 40 over 9. Next, I can go around the world here. 2 times 3, that's 6, plus 2 is 8. So this is 8 over 3. Remember, our denominator has to be the same, so I'm going to have to multiply this 3 times 3 to get to 9. So I'll have to multiply the top by 3 as well. That's going to give me 24 over 9. I'm adding these two numbers together, so That's going to give me 64 over 9. Remember, every fraction is really a division problem. This is 64 divided by 9. 9 goes into 64, well, 7 times, because 9 times 7 is 63. And that gives me 1 left over. So my answer has to be 7 and 1 over 9. Next, I'm multiplying fractions. And this is easy. I multiply the top number to the top number and the bottom number to the bottom number. This is going to be 18 over 63. I can reduce this by knowing that both of these are divisible by, well, you guessed it, 9. 18 divided by 9 is 2. And 63 divided by 9, that's 7. My answer has to be 2 over 7. Next, I've got a word problem. If 1 mile is equal to 4 kilometers, 3.5 miles is equal to what? Well, let's see. 1 mile is equal to 4. So let's see, 3.5 would equal what? Well, let's see here. It seems to me if 1 equals 4, I can multiply 4 times 3.5 to get my answer. Oops, sorry about that last one. There we go. And that's going to give me, let's see, 22, that's 12, 13, 14. And then we have 1 decimal placement, so that will be 14. Number 9, we're dividing decimals, and this is pretty easy. It's just like dividing numbers, except I have to remember the rule with decimals. If my divisor has a decimal in it, I have to move it over and make it a whole number. That puts my decimal place over here. 4 goes into 41. Well, 4 goes into 4 one time. 4 doesn't go into 1, so I have to put a 0 there. And then 4 goes into 16 4 times. So my answer should be 10.4. And my last one, I'm dividing fractions. When I divide fractions, I have to remember my rule. Keep, change, flip. I also have to remember that when I'm multiplying a negative times a negative, whoa, I'm sorry, let me go back to number 9 really quick. I see that I have divided a positive number by a negative number. And a positive divided by a negative is a negative. I'm sorry, I almost missed that. Okay? And now we have a negative divided by a negative. That's a positive number for sure. And now we have to keep, change, flip. This is going to be 5 over 11. We're going to multiply it, right? We keep the first fraction the same. Keep, change, flip. We change the multiplication. And then we flip the second fraction. So this would be 11 over 6. Remember, our answer has to be positive because we have a negative divided by a negative. We can use the butterfly method if we wanted to and realize that 11 goes into 11 once, and 11 goes into 11 once. So this is really just going to be 5 over 6. Because 5 times 1 is 5, and 1 times 6 is 6. All right, we went over all the problems in under 10 minutes. Hopefully you guys have breezed through the test just the same way. See you tomorrow, and good luck.